Morning, everybody. We'll be getting started in a minute or two. We'll just let the last few people join. Can everybody hear me okay? If I just get a thumbs up in the chat if you can hear me, and then we'll get started shortly. Okay, let's make a start now. So as always, we're going to start off with a little review of what you've done previously, just to reinforce that knowledge. So a for loop, you can do a for loop through a list. So you can create a list into a variable called names here using the square brackets is the syntax for the list. And then you can say for whatever variable in whatever other variable. And then you can loop through each of the items that are in that list and take some action. So those are for loops that you did several lessons ago now, and you've been using quite a lot throughout. So a for loop can also go through a string. So you can say for letter in and then provide a string, and then you can loop through each letter that is within that string. So in this case, it's making the word uppercase and printing out each letter. We can then also go through a range of values. So range actually just returns a list. So in this example here, we're calling range parentheses 1896, 2020, 4. And since we have three values in the range here, we have the start, the end, and then the amount that we increment each time. So we're jumping up here by units of 4. So what that's doing is it'll print out the years 1896, then 1900, then 1904, etc., all the way up to 2016. It won't include 2020 because it's up to but not including. So if you wanted the year 2020 to also be included, you'd have to change that second value to 2021. So that's another example of the for loops. So getting a little bit more fancy with them here, we can ask the user to tell us how many times they want to loop through. So here we're accepting a input from the user and we are casting it to an integer, and then we're storing that into the variable times to ask. And then our actual for loop, we're saying for x in, and then we're using the range statement again, times to ask. So we're going through, we're looping through this loop as many times as the user requested, and then we're asking them to input their name. So this would be a way to ask a user, how many tickets do you want? And then you go through and you have to assign names to each person's ticket, for example. So that's how we can do that with a for loop. We've then also learned about while loops. So the difference between a for and a while loop is that a while loop will continue forever to loop through until you break out of it, or until the expression becomes false. So a while loop is fantastic for when you want something to happen until another something else happens. So in this example here, it's going to continually ask the user to make a guess until they enter the number 4. So if the user always enters the number 6, it will never ever stop, and it would just keep asking them. So it's really good for this sort of application. It's good for validation, where you want to make sure you want to keep asking the user the same question until they've actually entered a expected value or have done something that you want them to do. So an example of a while loop here that is basically the same as a for loop, except using a while loop. So we've initially, outside of the loop, we set up a variable called times in loop. We set that to 0, and then our while loop says times in loop is less than or equal to 10. And then as part of that while loop, we actually increment the value that is stored in times in loop by 1 each time. So what this does is it'll go through, it'll print hello, it increments the value in time to loop, and it'll loop over all of that and print out hello 10 times. So it's very similar to a for loop, that example. So this is actually now showing you the difference between them. So with a while loop, you have to store a sort of temporary count or a variable outside of the while loop. So in this example, we're storing x, and then you increment that within the while loop. But as you can see, you don't need to do that with a for loop. You can just say, or you can just use the range to loop through the same number of times. So whilst the while loop there is 4 lines of code and a little bit more complicated, the for loop is only 2 lines, which is a little bit simpler for this particular application of just looping through something a given number of times. So again, you want to be using that while loop when you want something to continue until something happens that you don't know at the very output. So we then looked at collections. So you've gone through now the 4 different collection types within Python. Those are lists, tuples, sets, and dictionaries. So we'll just have a little refresher on each of those. So a list, hopefully you're very familiar with by now. So a list is defined using the square brackets. You then have the option to append to it. So you can say variable.append, and that adds a new value into your list. You can then directly reference each item within the list. So you do that using the index and the square brackets. So you can say their names, square brackets 2, and that will give you the third element that is within the list, because remember that Python always starts indexing from the 0 position. You then have the ability to delete individual items from the list. So using the del statement there. So that's deleting the second item that was in the list because it's referencing index 1. You then have the option to say if some sort of value exists in the list. So if Eve in names, that's checking to see if the value of Eve exists in that list. So that's an easy way for you to validate whether something is actually in a list or not. And finally, you have the option to also loop through each item in the list as part of a for loop. So you can say for name in names, and then you can loop through the list. So those are the common things that we've been doing using lists. Hopefully they're all very familiar to you by now. You will be using these a lot throughout your programming career. This is a standard thing that you will do day in, day out. So it's really important to know the basics of all these things. We then looked at a tuple. So a tuple here is defined using the parentheses. So it's similar to a list. However, once you've created it, you can't edit the values that are in it. So it's a what we call an immutable item. So you can't actually change the values once it's set. You have to create a completely new tuple. And again, you reference each individual item from within that using the square brackets and then the index. And again, Python starts from index 0. Then had a look at a set. So this is similar to the tuple. It's just a single value that you pass, and you pass these within the curly brackets. And again, you can go through and you can use these in a for loop, etc. So it's just another type of collection that you have the option to use. And then finally, we get to dictionaries, and a dictionary is this idea of a key and a value. So you create a dictionary and it contains as many key and value pairs as you want. So in this example, we have a variable called shirt. We create the dictionary, again, using the curly brackets, and then you define a key, which is on the left-hand side, then the colon, and then on the right-hand side of the colon is the value that you're assigning to it. And then since you provide a key for each of the items within the dictionary, that is how you then reference those values. So in a list where you reference each individual item using the index number, with a dictionary, you reference them using the actual keys that you provide. So in this example here, we can say shirt, square brackets, and then we pass in the key, which is size, and then that will provide us the value that is assigned to size. So with a dictionary, you can do all the same things that you can do with a list pretty much. So we can reference individual items from them. We also have the ability, instead of using the append statement like we do in a list, we can actually just directly state a new key and provide a value. So in this example, we've got material. It doesn't exist in the original dictionary that we created, but we're just referencing that key and we say it equals cotton. So that's how you assign a new value to a dictionary. You then also have the ability to edit a value in an existing key. So we're changing the color of the shirt from red to green. You can then delete them, again referencing the key name. And then you can do the same if and for loops with them. So the only thing that you have to watch out for here is that you're actually comparing against the key, not the value. So in if material in shirt, that is checking to see if you have a key in your dictionary that is called material. It's not checking to see the value. So that's how it slightly differs from a list. And then the same is true with the for loop, where you say for key in shirt, that is actually providing you with the keys of the dictionary. It's not providing you with the values. So again, if you want to get the value that is assigned to the key, you need to reference it using the square brackets in this example. So again, dictionaries are something that you will use day in, day out. It's a very easy way to get structured data. So by having the key and the value, you can easily describe what each part of your data is. And this is not as true with a list. So a list you would sort of use more for unstructured data, and then a dictionary, if you actually know what the data is that you're collecting, it makes more sense to obviously assign them with a key. So that's the dictionary. We then looked at nested collections. So this is sort of putting everything that we've just gone through together. So on this example, we have a list of lists. So the phone grid there is a list, but then each item within that list is also a list itself. So this is how you start to build up more complex data structures. So in this example, we are obviously showing you a phone grid. So, on every single phone, that should be how the keypad is sort of laid out. So that allows you to do this sort of two-dimensional layout of a grid. So this could be also very useful if you were, say, doing, a noughts and crosses board or a chess board, a checkers board, things like that. Anything that is two-dimensional, you can think about using a nested collection like this or a list in list to represent that. Then on the bottom here, we just loop through. So we go through each row to begin with in the list, and then for each item within that list, we go through the nested lists, and we print out each individual column. So now we come on to a list of dictionaries. So this is how you can collect multiple items of the same sort of thing. So in this example, we've got contacts, and that is a list. So you can have as many contacts as you want, which seems sort of a sane idea if you are making an address book or something like that. And then for each individual contact, for each individual contact, we have a dictionary, and then we have different values assigned depending on, I guess, what information we have about that user. So for Alice and Charlie, we only know their first and last names. However, for Bob, we also have a phone number. So it's just sort of showing you the difference here, that whilst you can have multiple dictionaries in this list, each of those dictionaries can be different. They can contain different amounts of data, different types of data. Again, this is the benefit of this key value idea within dictionaries. And then finally, the for loop on this slide, we're just looping through each of the contacts, and then we are checking to see if the dictionary for each contact has a phone number. So we're saying if phone in person, again, we're referencing the key in the dictionary, not the value. And if the person does have a phone number, we are printing out their first name. So all that code is going to do is print out Bob, because Bob is the only person who has a phone number. So again, as always, ask you questions either in the chat. Saf is in there today answering them in real time. If you've got any other questions throughout the week, you can answer them on Slido using the code Python 2020. I'm sure you all know that by now. All these details, again, they're all listed below the video. And let's crack on with the actual lesson. It doesn't look like anyone has too many questions. Yeah, I can't see any in the chat at the moment. So today we are covering functions. So you have actually already been using functions. We've just been calling them something different. But today we're going to go through, tell you what they are, why we'd use them, and obviously you'll learn how to create your own and how to call them. So the functions that you've already been using, and we've been calling them statements up until now, so we didn't have to explain what a function was. So you've got the print function. So anything that has the parentheses at the end that you've been referring to is actually a function. So the print statement is actually a function. All that does is it prints whatever you pass to it to the screen. You've been using the input function, which obviously takes information that the user enters and stores it to a variable. And then all of the different casting types that you've done, those are also basic Python functions. So the str, the int, obviously casting to a string and to an integer. And finally, the length, or the len, obviously was getting you the length of either a list, a string, etc. So you have already been using this idea of a function. So hopefully the next slide tells us, what is a function. So a function is a reusable, self-contained block of code, and that ideally should do a single task. So functions are how we write code that can easily be reused multiple times. So at the moment, all of your programs have been running from line 1 to line 2 to line 3 to line 4, etc., just straight down the page. We then obviously started to adjust which individual lines of code were actually run using the conditional blocks. So the if statement, we're going through and saying, well, actually, those 3 lines of code should be run, but these other 3 lines shouldn't be run. So functions allow us to do something sort of similar, where we write the code in once and store it within a function, and then we can call that function, and by calling it, we run that block of code. So instead of having to repeat and write out the same code multiple times, we can instead write it once, store it in a function, and then call it whenever we need to use it. So if you look back at the examples of the functions that you've already been using, the print function, if every time you had to print to the screen, you had to give the computer a load of information on how to actually do that process, it would obviously get a little bit repetitive when you kept printing things out. So the print function stores all of that logic about how to actually print a message to the screen, and then you can just pass it your string and it will sort of do the magic for you and handle printing things out to the screen. So I think I've probably gone through most of these now. So why do we use functions? The really important thing here is that it lets us reuse our code. So we don't really ever want to write the same lines of code multiple times. So that's a big idea of why we use them. And the second one is it allows us to break down larger problems into smaller ones that are easier to sort of manage and to allow multiple people to work on at once. And I think we'll go into some examples of those later on. But if you imagine a large complex system, we could plan out before we started writing our code how different functions would interact and call each other. And then we could allow different programmers to work on each of those individual functions themselves. And then you could eventually bring them all back together and you would have a completed solution. So let's actually look into how we go about creating a function, because this will again help people sort of get it set in their mind as to how these work and how you call them. So to create a function, we use the def keyword, so def, short for define. So we define a function. So use the def followed by a space and then followed by your function name. So again, this follows the same naming conventions as your variables. So try and keep things lowercase, don't use spaces, don't use any symbols, try and keep them just to lowercase characters. And I would personally replace, anywhere where there would be a space with a underscore. Once you've got your function name, you'll then add on the parentheses at the end. And that is then followed by, just like with an if statement, a colon. And then anything on the lines below that are indented become part of the function. So in this example here, we create a function called hello_world, and the code that would run when it was called is, the print hello world, so it would print out hello world to the screen. So again, notice how the function is named after what it actually does. So it's called hello world because it prints out the message hello world. If it did something different, obviously it should be named differently and appropriate to what it actually does. So the basic overview of how to create a function there again. So the keyword def followed by your function name, followed by your brackets and a colon. And then all the code that sits within that function is indented down below. So again, it should hopefully be sort of familiar to you by now, because this is exactly the same as how a if statement works, or a for loop, or a while loop, etc. It all follows this same basic sort of structure. So once you've actually written your function and defined it, the code doesn't actually get run until you then call the function. So in your code, you could define a load of functions, but nothing would happen until you actually call them. And to call a function, you just use the name of the function followed by the parentheses. So here again, we've got the same example that we created before, the hello world function. And to call it, all we do is write the word, we write hello_world followed by parentheses, and then that would execute that particular function. So if you didn't call the function, nothing would happen in your code. It only gets run when you call the function. I think that's an important thing to remember. So it's not like all the code that you've been writing so far. When you write it, you expect it to be executed. Anything that is part of a function will only be run when you actually explicitly call it. So a detail or another look at this. So when you print out at the start here, so I'm just getting this idea in your mind here that it doesn't get executed until you actually call it. So this example would just print out program starting, program ending, because nowhere in it do we call the function hello world. Okay, we're now going to go on to quite an important topic in programming, which is this idea of don't repeat yourself, which we often shorten to this idea of it being dry. So what we don't like in programming is repeating any line of code that is basically the same thing, because that means, one, there are more lines of code for us to maintain. That means that there could be more bugs for us to fix. And it also means that when we come to change something, we have to change things in multiple places as opposed to just one. So we always try to get to this point when programming. We refactor our code until we get to a situation where you have not repeated yourself. So we'll go through some examples of that, and this is what functions allow us to do. So anywhere that you would think about repeating your code, that's a good place to create a function and then call the function instead of repeating your code. So obviously on the screen at the moment here, we've got this idea of we're printing out the hello certain people's names 3 times. So hello Alice, hello Bob, hello Charlie. So when I look at that, I think, okay, I'm using the print statement 3 times and it's all pretty much the same. All that's changing is the person's name. So how can we go about refactoring that code to make sure that it is dry? So yeah, a little bit of explanation there. So printing it 3 times. So how do we do that with a function? So here we go. We've now defined a function called hello, and we have the ability to pass in what's called a parameter to a function. So to define a parameter that you pass in, you just within inside the parentheses, you enter a variable name, and that allows us to pass a value into the function, and then we can use that variable within inside the function to do some work. So this allows us to then call the hello function, and we can pass in each person's name. So I called the hello function 3 times here, once for Alice, once for Bob, once for Charlie. And because I pass in that parameter, each time that gets executed, it will print out a different hello message. So this is going to print out the hello Alice, hello Bob, hello Charlie. However, we're not repeating at least that print statement. So parameters are really important with functions, and it's how we make reusable functions. Without them, obviously everything is a lot more difficult to reuse your code. But as you pass in parameters, you can change out individual bits of your code and obviously adjust them each time that you call them. So again, that's reiterating here that we're only changing the message in one location. So here we want to change our message to good morning as opposed to hello. So now, because we've put that in a function, we only have to change the message in one individual line, and it will change the output of the entire program. So we've gone from sort of this code here. So hello Alice here. We've written it 3 times. We've then said, oh, well, we changed the message. You have to change the message in 3 different locations. Obviously, you're likely there, if that was scattered out over a large program, you would miss some of these instances. So you would probably end up with bugs if you were just changing those manually. We've then changed it to a function that accepts a parameter. And then once we've got that function, in order to change the message from hello to good morning, we only change it on that one individual line, and it changes our entire program. So that's the idea of keeping things dry by using parameters. And then going further on to the next sort of logical step there, you obviously see here that we're calling the hello function 3 times below. And again, that should be sort of ringing some alarm bells in your head that, oh, what happens if that function name were to change? Or perhaps you wanted to call a different function. So the final example here that we have, we create a list of all of our names that we want to go through, and then we want to loop through each of those names, and we call our function from within that. So that would mean if I now wanted to change the function to a good morning function, I would just have to adjust one line of code in order for all of that stuff to work. So anywhere that you see that you're repeating your code, try and use a function to separate what code you're executing, and that just makes it easier to sort of maintain, and you keep this DRI principle of don't repeat yourself. So let's have a look at more parameters within functions. So on the previous example, you saw that we passed in a single parameter. we have the ability to pass in as many parameters to a function as you want. All you have to do is define them. So in this example, we are creating a function called hello, and it's accepting two parameters. The first one is name, and the second one is age. So notice there that within the parentheses, we just have the variable name followed by a comma, followed by the second variable name. And that has allowed us to pass in two different values. So you notice when I call this hello function at the bottom, and this time I'm passing in the person's name, so Alice, and then a comma, and then their age, so 22. So whatever parameters I've defined as part of my function, I can then pass in when I actually call the function. So again, you can pass in as many parameters as you need into a function. So another example here, we've still not updated this slide to say that this isn't area, it's volume. So we do apologize. So this here, we've got a function called area, which should really be called volume, but then it accepts three different parameters, x, y, and z. And then it obviously calculates the volume of those three numbers, and it prints out the message. And then when you're calling that, you just call the name of the function and you pass in the three variables. So again, just that idea here that a function can have as many parameters as you want. So use the define keyword followed by your function name, followed by the parentheses, and then inside the parentheses, you list each of your individual parameters and you separate them by a comma, and that allows you to pass in the parameters. Okay, so we're now at coding time section A. So we're going to allow you to look at the questions. So hopefully Saf has posted the questions below the video. If you can't see them, refresh the page and I'll show them on the screen for those that can't see them. So this is the first set of questions, and it's just going to have you create some basic functions. I'll give you a few minutes to have a go at them yourself, and then I will do some live coding to show you them, just to remind you about the syntax. But I'll just give you 2 or 3 minutes just to start to have a go yourself, and then I'll come in and show you the coding. Okay, I'll just start to now show how you define a function. So I'll probably start off with the first question and then we'll just take it from there. So the first one is write a function that will print your name. So before using a function, obviously you could just start off with a simple bit of code here. So print Jake. So I'll run that and obviously it prints out Jake, but then this idea that like, oh, what happens if we want to run that block of code again? So here we want to print Saf's name, so I'll run that. So again, it prints out what we're expecting, it prints out people's names. However, we're calling the same thing. What happens if we wanted to add more information here or do additional things? So we say that, Saf is 22 or something like that. If we wanted to have additional information, we start to then have a lot of code that will start to repeat itself. So to define a function, we use the DEF. So we'll define our function and we'll call it, let's just call it hello to be simple. So I'll put the parentheses at the end and then it's followed by a colon. And now whatever code I put in here that is indented, so REPL helpfully indents my code when I hit return. So here I could put in the code print Jake. So let's just delete those for the moment. So now if I've just defined that function and I run my code, we'll notice on the right hand side that nothing happens. So this is this idea that when you define a function, none of your code is run until you actually call it. So now let's call it. So I just type in hello, which is the name of my function, followed by the parentheses. And I've now called the function. So I'll run the code again. And we'll see now that it runs and it prints out Jake. So obviously I can run the hello function multiple times here. And it prints out whatever is defined in the function. So obviously that's not overly useful at the moment because I've hard coded my name in here. So now let's look at how we pass in a parameter. So parameter we first of all define as part of the function here. So I know that I want to pass in the person's name. So all I'm going to do is title name there. So I'll run the code again now and we'll see if we get any errors. Okay, so I get an error now. So I'll come down and I'll read the bottom line of the error and it says that hello, parentheses, so it knows that we're talking about a function, is missing one required positional argument of name. So this error is typical, you get it quite a lot, and all it is saying is that this function is expecting a parameter to be passed in, and unfortunately when we're calling our function, we are not passing in a parameter. So to fix this, we just have to pass in a value. So I will now pass in my name and I'll run it again. So as you can see now we're printing out Jake. So I will now copy this line of code and I'll now try and get it to say Saf. So I'll run that again. Okay. So now we see another error. So I run the code and I was expecting it to say Jake followed by Saf because that's what the value I've passed in is. So I'll come back up and I'll look at our function. So the variable we're passing in is name. However, we're still printing out the hard-coded value of Jake that we've got in there. So what we need to do is change that to actually use the variable called name. So I'll change that, run the code again. And now you can see the output here of Jake and Saf. So that's a very basic sort of function there. So let's make it a little bit more complex and let's put the person's age in. So I'm going to add a second parameter to our function. So I've done the comma followed by our second one. So this will be their age. So I'll run that again. So notice I'm making small changes and then I run my code again. So here I've got the same type of error as before. We are missing one required argument of age. So when I'm calling my function, I need to put this in. Let's make sure that, so we put in the different values of the age. We'll run it again. We'll notice now that the code is actually working. We don't get any errors. However, we're not using age anywhere, so it's not showing anything. So then we could start to edit our print statement. And again, we're just going to concatenate the value. So we probably want age plus a blank space, or perhaps is, let's think. So we'll put in the age, and then we'll put in another string, and we'll say years old. So let's run that. Again, we'll see if there's any errors. Okay, so I've got another error. I can only concatenate strings, not integers. So when I've passed in the people's ages as parameters to the function, I've not casted them. So I need to just change that age integer into a string, and then we'll run that again. And now we get printed out the message, Jake is 22 years old and Safi is 21 years old. So again, obviously you can hopefully imagine that this function could get more and more complicated and have multiple lines of code, and it could process information. But again, we only hold it in one place. You don't have to repeat it on multiple lines. So let's have a look at the other one. So let's define another function called volume. So volume, that's going to take an x, a y, and a z. And this will then print out the volume of that. So we'll just print out the value of x times y times z. So we'll keep it fairly simple to begin with. And I'll now call it a few times. So volume parentheses, and then I need to pass in the three values. So 1, 2, 3. Again, this idea that we can replicate things. So let's get some of the values that we might be able to work out ourselves. Times 3. Let's make a big one. So I'll run that code again, see what happens. So now we're starting to get our volumes created here. But you can imagine now, like, well, actually, what happens if I'd accidentally, I'll start off here and I've written this code and I got a bug in there. I thought that the volume of an object was just each of its sides added together. So I'll run that again. It's like, oh, well, actually, those values are not correct. If I had, copied and pasted this line multiple times down here, so if I'd done 1 plus 2 plus 3 here, and I've done that on multiple different lines. So I've now got bugs on 3 lines here. So to fix this issue, I'd have to change these plus symbols multiple times on multiple lines. So the benefit here of having the function is that I've only made the error in a single location. So I can change it in one spot. And now when I run the code, it fixes it for every single person that is calling that function. So that's one of the important things about using a function. So hopefully that explains the questions in section 1, and it gives you some idea of how to create and how to call a function. So we'll jump back now to the rest of the lesson. And we'll learn some more stuff about functions. So functions, as well as accepting values, they have the ability to return values. So what this means is that when you call a function, you don't have to just print the message out. You can actually have it return some information. So to do this, we use the return keyword. So again, this we've not renamed area to be volume, so please forgive us. But inside the function, we use the return keyword, and then we are passing back a value. So it's the volume of the cube or whatever. And you just use the return keyword and you pass it in whatever value. The important thing to remember about when you use the return keyword is that the function will completely stop running at that point. So as soon as it hits a return, it will return execution back to the point in the program where you called it from. But what happens here is that cube1, so when a function returns a value, we can store it inside a variable. So now when we're calling our function, we call it first of all by declaring a variable, and then that equals the result of a function call. So cube 1 will obviously equal the value of 12 times 3 times 4, and then cube 2 will obviously do the same. So this is really good for, again, making functions reusable. So a lot of the time we don't want functions just to print information out to the screen. We want a function to calculate something or do something, and then pass that information back so that the rest of our program can actually use the information that it calculates. So again, this is the overview of how to use the return keyword. So you define your function can again, calculate, do anything that it wants, and you use the return keyword followed by whatever the value you want to return. So you pass in your parameters and then you return information. So this now completes this idea that, like I said, a function is this black box. You don't need to know what it does inside of it, but you can pass information into it. The function itself will do something to that information, and then it will return a result out of the other side of it. And that's how we often think about functions in programming. So the next idea that we had right sort of, I guess, closer to the start of the lesson was the DRI principle. And when we declared what a function should be, we mentioned that a function should just do a single job. And again, this helps us with making functions that are reusable. So if a function did, like 10 different things all together, if I then just wanted the piece of code to do one of those things, I couldn't actually reuse the function that you'd made. So it's really important that a function only do a single thing, and that makes it really, really reusable. So from the previous example we had this one function that, it printed out the message, hello, my name is whatever you passed in, and then it calculated how old you would be in 10 years' time. That was obviously then doing multiple things, because I might have another use case where I want to calculate how old someone is in a certain number of time, or a certain number of years. So here we've just broken out our original function, and we've created two different functions. So the second one here is this age in X years. And then we're passing in two variables. One is the age and then the years. And now we have an individual function that will only calculate how old somebody would be in X number of years. So in this example, we want to know how old they will be in 10 years' time, but this function allows us to obviously pass in a different number of years. So we could use it to work out how old somebody was in 5 years, in 50 years, in 100 years. And that function is completely reusable because it does a single job. So another example of a single job function will be this. So again, you've done this in previous weeks. You've worked out if a number is odd or even. So here we're going to define our own function called isOdd. We're going to pass in a parameter called number, and then the code inside our function will work out if that number that is passed in is odd or even. It'll return true if it is odd, and it'll return false if it's not. So we do our modulus calculation here, so using the percentage character. So we say if number modulus 2, so if it completely divides by 2, we want it to return, if it doesn't completely divide by 2, aka it leaves a remainder of 1, that is true. So that would be if true. It then returns the value of true, and if it's not an odd number, obviously the modulus would return 0, and therefore the code drops down to that final line and it returns false. So notice here that we have two return keywords as part of this function. So that's allowed, but only the first one will be executed. So only the first one that your code executes will actually be run. So if the if statement is true, it will run the return function that is part of the if statement. Otherwise, the code will carry on executing within that function and it will return false. So you can have multiple return statements as part of a function, but as your code is executing line by line, depending on what pathway it takes inside that function, you could break out and return from that function before you expect it. So that is one thing to watch out for. Obviously, if you'd also introduced a bug here as part of your if statement, you might always end up returning true and you might never hit the return false. So that's also another common bug that you might run across, is just your logic is slightly out so that your program is returning early. Okay, we're now going to look at an idea that is called recursion. And what recursion is basically a function calling itself from inside that same function. It's quite it's a difficult idea to sort of wrap your mind around, I guess, until you actually see it in action. A classic example of this though is working out a factorial. So a factorial is obviously different. Each so like a factorial 4 will be 4 times by 3 times by 2 times by 1, etc. So this is a classic example of how we can use recursion to calculate that. So we're going to define our function. We'll call it calc underscore factorial, and we'll pass in a variable called x. That'll be our number. We then have some logic inside of our function. So we're going to say that if x equals 1, we just want to return the value of 1. Otherwise, we want to return the value of x multiplied by, and then we're passing, or we're calling the same function that we are already in, but we're calling it with 1 less than what our current value of x is. So here we loop through. So if you gave the number 5, the first time it runs through x equals 5, it would then call its own function and pass 4, and then that would call itself again, and it would pass the parameter of 3, then it would call it again, it would pass the parameter of 2, etc., etc. So on this slide here, we sort of break that down as to how it's actually calling it and what this second or the else part is actually calling. So when you first call your function, you'll call calc underscore factorial 4. So that's our first call of the function. Then the else part of the if statement is executed. And what's in the brackets there is basically, it'll be 4 times by calc factorial 3. Obviously, x is 4 to begin with, and then the parameter that we're passing to calc factorial is 4 minus 1, so that's 3. It then calls that again on the next calling of the function. So this time it's 4 times 3 times calc factorial 2. It's then 4 times 3 times 2 times calc factorial 1. When you hit that function with a 1, it obviously just returns a 1. So we no longer are calling the function itself again. And then it works its way back up the sort of stack here. So now that we've got all of the values, it then starts to multiply them together until you get 24. So we do have some example questions that we'll get you to go through just to give you this idea of recursion. Again, it's quite a difficult one to sort of get your mind wrapped around. So don't worry too much if this sort of isn't making too much sense at the moment. On Thursday's lesson, when we go through the answers to some of the questions, we should get that set in your mind. And that leaves us there at coding section B. So again, the questions are below. Let me bring them up for people as well. So again, all we're trying to get you to do this week is write a lot of code that I think you've done a fair amount of it before in other lessons. We're just trying to get you to put all of that code into functions and get this idea across that functions allow you to write your code once and then reuse it, which is really important, obviously, to get around this DRI principle. But yeah, those are the questions. Let me check the chat to see if there are any specific questions that perhaps I can go through and answer. And if not, we're sort of coming to the end of today's lesson. We finished nice in time. So if anybody wants to post any questions in the chat, I can go through them. So it's question 3 or B3 this week, where we're trying to get you to do this recursive function. So what it should allow you to do is enter a number and then print out that number of stars, and it will go down to, if you print in number 5 to begin with, it'll print 5 stars, then it'll print 4 stars and 3 stars, then 2, then 1. So that's our example of a recursive function this week. Everything else, as I say, I think you've pretty much done on in previous lessons to some extent. It's just trying to get you to put all of that into a function. Okay, yeah, so again, a little bit of confusion still around the recursion. So if you just think of recursion as a function calling itself from within the function, there are different times in programming when you'll want to use them. There are also a lot of times when you won't want to, but just have a go at question 3 or B3 and you'll be able to hopefully get a better understanding of it. You really need to do it yourself to get a good understanding of it. Can you do recursion again? So we're not going to answer any of the questions, so I'll skip that. Set a Q5. What's so A3. Okay, so I'll come off these. So the questions for these are below the video. So I've just got a request to go through A3, which is to loop through the list Alice, Bob, Charlie, and call the function that we just wrote. So let me bring up my REPL. So get rid of some of this. So we've got our function here that is accepting 2 parameters. We've got the name and the age. And now, so let's imagine, for example, here that, I've got loads of different people that I want to call on this function here. Okay, we'll give people different ages. Okay, so when I run that code, we get our expected output. I mean, hopefully that's a given to a lot of people. But now we're calling this same function 4 times. So for question 3, what we're looking for is, instead of having all of this information sort of hard coded here, we're looking at you to store it inside a list. So for the actual question, I don't think we have an age. So let's just get rid of that age. Let's just have it print name to keep it simpler. So I'm going to create a list of names. So names equals square brackets, and I'll put in the same people that I've got below. Okay, so I've now got a list of names. So instead of repeating this line multiple times here, I'm going to loop through. So I'm going to say that for name in names. So each time we loop through here, we're going to have a new variable called name that is going to contain our name. I'm going to call the hello function, and I'm going to pass in name. So I'll just comment that out. So I'll run the code again. So you'll see what happens here is we've got our list. We then loop through each of the lists, and then we are calling our function, passing in that value each time. So this then allows us to say, well, actually, Saf isn't called that. She's called Safia. So we'll do that. We can change it in one place there. It changes it. We can then say, well, actually, no, this function, it doesn't say hello. It's just calling about someone's name. So let's say this is now called print name. So if I run that again, we'll see an error. So hello name is not defined. So it's basically stating here that we're calling a function called hello, and we've not defined that function, and that's because obviously I just renamed it. So again, that's another sort of common error that you might see. So if I go in here and I do print name, I'm referencing the new name of our function. So I'll run that again. So now it prints out the same results. I also just want to show you here that the names of the variables that are inside functions, they're sort of within their own scope, we call it, so that you can use the same variable names. So notice here that I've used the variable name here and I've passed it, and it's also used in the function. That's perfectly fine. I just want to prove to you that you can obviously call these anything that you want. So I could just change that to X, and then I can print out X. As long as whatever you're calling your parameter in the function, that's what you're using inside the function, it will still work. So you see I get the exact same result there. Obviously, it just makes a lot more, it makes it a lot easier to understand what's going on if you use sensible variable names and parameter names. So again, that's the same code there. So hopefully that answers A3, spaces, new lines. Okay, looks like Saf's answering most of the questions in the chat. Again, obviously, everyone can remember the REPL is open all week. So if you do have any questions around any of these, anything that we covered today, please post them into Slido and we will respond to you. And if you don't have any further questions, the next session is, as always, on Thursday. We'll be going through the answers to all of the questions today. And yep, that's everything. So we will see you on Thursday. As I say, post any questions into REPL if we've not had a chance to answer you in the chat today, and we'll get back to you. But we will be going through all of these answers on Thursday as well. As always, you can rewatch this video as many times as you want, both on Twitch and on YouTube. So if I have gone over things too fast, you can go back and watch it at your own pace. Or you can rewind segments to have a look at the code examples, etc. So please do make use of that if you are struggling a little bit. These concepts are obviously getting harder as we go through the weeks, so we don't expect everybody to pick them up straight away. But again, practice your coding. That will be how you learn this stuff. It's not something that you can just pick up by watching the slides. You do have to actually practically use it. So please have a go at attempting all of the questions, and we will see you on Thursday to go through all of the answers. Thanks a lot for joining us today. We will see you soon.